Alright, so this is just a quick short video on one of my projects that I've been working on for a while now. This is a SAMD21 based VFO. The clock generator board itself is a SI5351 clock generator board from Adafruit. In the future, I'd like to break out the clock chip by itself without having to buy this subboard on the bottom here. I've just got this 3D pen created case for it so it doesn't sit on some kind of conductive piece of scrap that I have around my desk. So this thing uses just a really simple OLED display that operates on the same I2C bus as the clock generator board, and it has an encoder as its only means of input. So it's taken me a while to get everything working here. Obviously the clock generator board itself isn't very hard to get working, but the UI has taken me a long time to get working properly. So just as a quick example here, I'll go over to the VFO page. You can kind of see how it works in this mode. You can just scroll with the encoder to set the clock, and you have access to all three clock outputs of the SI351 board. So that one's at 20 megahertz. I have it capped at around 1 megahertz and I believe 200 megahertz. This thing will not output 200 megahertz on every channel, but that it will on at least one channel. So back in the settings, if I scroll over there, things I've placed in here so far are is the power output. I believe that can be chosen per clock, but I've just set it for every clock in one setting right now. Phase shift and phase enable. This will allow you to change the phase between two different clocks for things like mixers or phase shift keying. I don't know. I have a step setting, so if you're using it to just control a radio, you can scroll up and down in different steps. There's an entry mode. I don't know if you can see that. It's currently in edit. That was the mode you were seeing me use in the VFO page earlier, where you can just change single digits by themselves and kind of just scroll through from the ones to millions position. You can also enable or disable every clock and invert every clock if you feel like it. So if you were to run something like a Class D amplifier in a current mode configuration, you would need two complementary clocks, and this could do that, although you would need an amplifier. So version 2 of this is going to have a modular output header. So in addition to these clock output SMA connectors, there will be a double row pin header at the 2.5 millimeter spacing. So that will allow you to do things like mixer boards, amplifier boards, just general hobby boards attached to your VFO directly. That's the idea anyway. So in general, it's a cheap benchtop VFO that you can program yourself, you can modify the UI, and it just lets you have a complete control over your clock gen board without having to do a whole lot of programming. Anyway, I'll probably post the code in the video description. I can post the KiCAD schematics and files if anybody is interested. You can see there's some things that I didn't actually populate on it. That's for audio input to do frequency shift keying. One of my brother-in-law has that working, but I haven't played around with that very much. Anyway, thanks for watching.